All right, so this is method 4 of trigonometry. We're just trying to find an unknown angle, and we're looking at this right triangle, which looks a little bit scary, but is actually really simple. And we're trying to find measure of angle K. Now, the ratio that we can use is based on the sides we have, based on the angle we have. So we're looking for angle K, and we have opposite and adjacent to angle K. And because we have those, we're using tangent. Tangent is the only function that has opposite and adjacent in it. That's why we're using tangent. And if you remember SOHCAHTOA, you can figure out which function has which sides in it. SOHCAHTOA, TOA is tangent, opposite, over adjacent. So, okay, I know I need to put opposite over adjacent. Now, to do that in my calculator, it looks a little scary because I have these 36's next to the square root of 2. In fact, the square root makes it look crazy too. But it's actually much simpler than it looks. If I know that this is, a proportion, in fact, I can cut the problem in half right now. Because look, they both have 36. If I divide 36 by 36, it's 1. So the 36 in this problem is meaningless. If I do 36 divided by 36, it's going to do nothing. It's going to make 1. It has no change on the proportion. But when I do square root of 2 divided by square root of 6, that will give me something useful. So I can do square root of 2 divided by square root of 6 somewhat easily on this calculator, and I may mess up. Square root of 2 divided by square root of 6. And then I can put this into my inverse tangent function. Inverse tangent. So that means tangent to the negative 1. And you see, I messed up on this because I was supposed to hit equals before I hit tangent of negative 1. So let's try that again. Square root of 2 divided by square root of 6 equals point blah, 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 blah. And I'm going to do inverse tangent. Inverse tangent's pretty easy. And look, it was 30 degrees the whole time. So I'm going to put 30 degrees in for angle K. Fantastic. Now, look at this. This is even easier. Because if I look at this, all of a sudden, if I divide these, they're the same number. So this is really a ratio of 1 over 1. I don't even have to divide 1 by 1. So let's look at which function to put it in, because we still have to know that, at least. We still have to know which function to put it in. So I'm looking for angle P, and I've got opposite over adjacent of that angle P. Remember, this is the hypotenuse right here. And so I'm not going to be putting the hypotenuse in, because I don't have it. So again, I'm using tangent, and I'm dividing opposite by adjacent, so I will get 1 over 1 because it's the same number. So if I put 1 into inverse tangent, this is what happens, 45 degrees. This is a special triangle. This is going to be the ratio of this special triangle where both angles are 45 degrees is 1, 1, square root of 2. So I'm just going to put 45 degrees in for angle P. Simple as pie. Easy, right? All right, let's go down one more. Find angle E. Let's see, angle E. So I have hypotenuse and adjacent, so I have to put that in cosine, because cosine, ka in SOHCAHTOA, is cosine equals adjacent over hypotenuse. So I'm going to put 3 divided by 7 into inverse cosine. All right? So 3 divided by 7, inverse cosine. Oh, wait, got to hit my equal sign. Inverse cosine, and there I go, 64.62 degrees. Now, I can put it in as a decimal rounded to the nearest tenth. So that means I'm going to stop right here at the tenths, look at the hundredths, it's less than 5, so that means 0.6. So 64.6. I'll do that right now. All done. All right. Send me a message if you need help.